So here, 25 is being raised to the first power if it's not written. And your index, the number on the radical, like the fourth root, the third root, the square root, is the bottom. So this would be 25 to the 1 over 4.
What's that number right there to represent the 25?
A 1. Yeah, 25. A whole number is always being raised to 1. And then going opposite, if you're given exponential form to write it as a radical, the top is the power. So this is 5 squared still. And the 3 is your root. So third root of 5 squared. So it's just kind of knowing where to place those numbers. 5 is being squared. Another way to write this is you can write the cube root of 5 and then square it.
So the denominator is always on the outside and the numerator is always on the inside.
Perfect. The denominator is always on the outside of your radical. The numerator is always on the inside. Cube root of negative 1,000. We broke down 1,000 yesterday. Yesterday? I think it was yesterday. But just to save time is 3 2s and 3 5s. 3 2s and 3 5s and a negative. The cube root of a negative number is just a negative answer. The square root of a negative number is imaginary. Do you want me to write what I just said?
Yes.
The cube root of a negative number is a negative answer. The square root of a negative number is imaginary. Because you can take a negative times a negative times a negative. Three negatives will give you a negative. But you cannot do that with 2 negatives, which is what's forcing you to work with imaginary numbers. Because a negative times a negative is a positive. So this is technically not physically able, which is why it's imaginary. Why?
That makes no sense.
Somebody discovered that it works.
Square root. Wouldn't it just be 1?
No. All right. So a negative cube root is just going to give me a negative answer. And square root, every 2 1 comes out. Cube root, every 3 1 comes out. So 2 comes on the outside. And a 5 comes on the outside. So negative 10 is your answer. Because negative 10 times negative 10 times negative 10 is negative 1,000.
Where did you even get those numbers from?
1,000? I broke down 1,000. We did it yesterday, so I wasn't going to waste our time. So 5, 2, 5, 2, 2, 5. So 3 2s and 3 5s give you 1,000. So if you have a negative exponent, you drop the whole number to the bottom and make it a positive exponent. And then we have to simplify. So this, write it in radical form because you really can't simplify in exponential form. So this is the 5th root of 32 squared. Fifth root of 32. We can actually simplify. Because 32 is 2 times 2 times 2 times 2 times 2, 5 2s. So every 5, 1 comes out since it's a 5th root. So I ran out of room. I'm going to have to write in the 8. So that's 1 over the 5th root of every 5 1 comes out. That's just what 5th root means. So that's 1 over 2 squared, which is 1/4. I don't know. I'm writing at the bottom of the screen.
I thought the other numbers don't disappear.
What other numbers? How come they do?
Yeah, why are they disappearing?
The easiest way to show it is to go back to square roots. So like the square root of 9. Do you know the square root of 9? What is it? 3. So it's 3 times 3. Every 2 1 comes out because the square root of 9 is 3. So the other numbers do disappear.
I understand that, but I'm saying like the 16, the 8, and the 4. How come those aren't staying in? I thought those were supposed to stay in.
Because they broke down more. You do the very bottom of them. Because you don't use 16 because 16 is a composite number. It's not prime. You only put the prime numbers in. So if there's a number that multiplies to give you another number, it doesn't go under the radical. All right, number 9, negative 27 is being raised to the 4/3. So the bottom goes on the outside, the cube root of negative 27 to the 4th power. You can do the 4 on the inside, or you can do the 4 on the outside. In this case, it makes more sense to cube root it and then take the 4th, then raise it to the 4th power. So I'm going to put it on the outside. Remember, right up here, a negative cube root is just going to be a negative answer. And 27 is 3 times 3 times 3. So that'll be every 3 1 comes out because we're grouping in 3s. So negative 3 to the 4th. And I'm wrong. Only the 27 is being raised to the 4/3. Otherwise, it'd have to be in parentheses. And it's not in parentheses. So only the 27 is being raised to the 4/3. So we're just going to put negative in our answer. So since it's not negative 27 to the 4/3, only 27 is being raised to the 4/3. So 3 times 3 times 3 times 3 is 9 times 9. So you'll get negative 81. I'm going to erase this so we can see that negative sign a little better. So negatives on the outside. The negative would be on the inside if it was parentheses negative 27. And that would cause you to have a positive 81 for an answer. Evens, I want to just talk about them a little bit. When you multiply like bases, what do you do to their exponents? Add. So you'll be adding those fractions together. When you raise a power to a power, an exponent raised to an exponent, you multiply. And when you divide like bases, you subtract your exponents. So on 11, I'm going to multiply my exponents. So 4 to the 2/3 times 1/2. Oh, that's this. With fractions, you multiply across the top, across the bottom. Common denominators when you add and subtract. Or just put in the calculator. and then reduce it. 2 over 6 is 1 over 3. And then on the test and on this review, leave your answer in radical form. So 1 over 3 is the cubed root of 4. To the first power, but you don't have to write first power.
When you're subtracting exponents, do you like on 12, would you subtract 1 over 8 minus negative? What would it be?
So 1/8 minus negative 1/8.
So it goes from the numerator.
Yes, top minus bottom. All right. On 13, you're taking the cube root of both of these numbers and squaring it. So that's what this means. You're taking the cube root of 27 times 64 and then squaring it. You can multiply these two numbers together, but then you have to break down a bigger number. Does that make sense? So there's really no point in multiplying them just to break them down later. Might as well just break down 27 as 3 times 3 times 3. And 64 is 4 times 4 times 4. Or 6 2s. And that's the factor tree I'm doing. All things being squared. Every 3 1 comes out because this is cube root. So you have 3 times 2 times 2. So 12 squared, which is 144. There are not many cube roots that we can really work with because if you, without getting the numbers too big, because 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. Now we're already in 3-digit numbers, and I'm not trying to give you a huge number to work with. So if I was going to memorize some cube roots, it'd be these first at least 3. I guarantee you'll see the cube root of 8 on your test. Cube root of 8 is 2. Cube root of 27 is 3. Cube root of 64 is 4. So those are the numbers. Like I'd go ahead and memorize a few of them just to help make your life easier. Because if you had known those, cube root of 27 is 3, the cube root of 64 is 4, so then I could have jumped straight to 3 times 4 squared. So 12 squared is 144. Now I wouldn't have to break them all down.
Oh, is that okay? I did that.
That's perfect. Yeah. That's fine. Show as much work as you need. All right, multiplying radicals. I think that was the second day of radicals when I wasn't here. Multiply what's outside your radicals together and what's inside your radicals together. But they have to be the same radical. So I can't do that on 14 because this is the square root and this is the cube root. So I can't multiply those together. So change it to exponential and add your exponents to simplify it. I can multiply 2 times 24 and get 48, but then I'd have to break down 48 instead of 24. I think that's right. 2, 4, 8, 16. 16 times 3. Great. Fourth root. Every 4, 1 comes out. The others go away. So 6 times 2, fourth root of 3. When you multiply 2 times negative 7 square root 3, the 2 is on the outside, so you multiply with the outside of the 7. So negative 14 square root 3. Square root 3 times 4 is 4 square root 3. And square root 3 times negative is negative 7 square root 9. When you have like terms, meaning they're both the square root of 3, you add their coefficients. Negative 14 plus 4. Negative 10. You know the square root of 9? 3. So 7 times 3, 21. So 8 minus 21. 26. 8 minus 21. 13. Way off. Negative 13 minus 10 square root 3. Nineteen's probably the easiest one on the sheet. They're both the fifth root of 4, so you add their coefficients. So 2 plus 4 gives you 6. You don't add anything else. That's just it. Add the coefficients. As long as they're the same radical, both fifth root, same number underneath, radicand, add the coefficients. On 20 and 21, if they're not the same one, see if you can simplify it into the same radical. So we can simplify 18 into all of its prime numbers. And 50 every 2, because this is square root, every 2 1 comes out. So 6 square root 2 minus 15 square root 2. And now they're both like terms, and you can add the coefficients. So negative 9 square root 2. So that's what you'll do on 20. Rationalizing the denominator is a lot like what we were doing today with complex conjugate, trying to get the radical out of the denominator. So you multiply the top and bottom by the same radical. So that's rationalizing. So you multiply the top and the bottom by the bottom radical. That way you can get the radical out of the denominator. So 15 square root 5. The 15's outside the radical, the 5's in, so you can't multiply them together. They just sit next to each other. But on the bottom, both of the 5's are, so you could multiply those. Simplify. And this should always simplify to get you just whatever you multiplied by, basically. Square root 25 is 5. And then the last step, 15 divided by 5 is 3. Square root 5. You can't simplify this 5 and this 5 because this is under the radical and that one's not. Absolute values, I didn't even go into that depth. Inappropriate. So we're just taking the square root of 81x squared. And remember, with exponents, with variables, you're just grouping them as well. 81 is 3 times 3 times 3 times 3, x times x. So every 2, 1 comes out. Every 2, 1 comes out. So you get 9x. Square root of 81 is 9. Square root of x squared is x. Nothing's left in the radical. The last half of this page was all on your last test. It's all your graphing and transformations, but this is just strictly on radical equations. So that's what you did on Friday. So you have to know that equation still from last chapter. The negative is a reflection of your x-axis. The a, if it's greater than 1, it's a vertical stretch. If it's less than 1, in between 0 and 1, it's a vertical compression. If the h seems positive, then it's going to the left. Negative is to the right. The k, positive is up. Negative is down. All right, I don't like it. Positive is up. Negative is down. So all of this is just saying, how is this equation, how is this graph, when you graph this equation, changed from this graph? So your parent function is the square root of x. How did these numbers affect that graph? So the 2's in front of my radical, greater than 1, vertical stretch. So vertical stretch by 2. Inside the radical, plus 5. Inside my radical is left and right, plus is to the left. So left 5. Because I had to actually plug in a negative 5 to make it look positive. So negative is to the left. What about 1/3 in front of your radical? Vertical compression.